In this lecture, we'll complete the algorithm analysis for the operations, the methods, in our stack class. We'll start with the push method, and the push method simply calls the list add method, which we know from our previous algorithm analysis is order 1 if we don't have to expand the list, and order n if we do have to expand the list. And so we often call this order 1 amortized, but in the worst case, this is order n. And you should go do an in-video quiz to make sure you understood that. For the pop operation, this is a constant time operation. This is a constant time operation. Looking at the end of the list is a constant time operation because we can access any element of a list in constant time. The remove at method is constant time because we're moving from the end of the list. If we were actually moving from element 0, we would be paying an order n cost, where n is the number of things in the list, because every other element of the list would have to get shifted down one. So this is actually one of the benefits of using the end of the list as the top of the stack, is that we get constant time for the remove at, and of course return is constant time as well. So you should now go do an in-video quiz saying what the complexity of the pop operation is. And because it's all constant time in here, it is an order 1 operation. The last one to look at is peak. And again, constant time, and constant time. So you should go do an in-video quiz about this. And the answer is this is also constant time. So this is pretty efficient as a data structure. Pushing is mostly constant time unless we have to grow the list that holds the contents of the stack. Popping is constant time and peaking is constant time. We do convert to the string, and this is of course order n because we have to look at each element in the stack to print it out. But remember, this toString is for debugging because we don't really want to expose to consumers of the class what all of the elements in the stack are. We want to enforce that they can only see the top of the stack. To recap, in this lecture, we got more algorithm analysis practice, and we also learned that pop and peak are always constant time, order 1 operations, and push is usually an order 1 operation, specifically when we don't have to expand the list that we're using to store the contents of the stack.